What I'm going to demonstrate at this time is Ciena's vSwitch's traffic management capability, and more specifically the egress shaping, class of service mapping, and scheduling capabilities. Now, in a traditional pipeline, data path pipeline for Ciena products, what we have is an ingress pipeline in which when a frame comes into the device, into the NID, it gets parsed, classified to identify what flow and what actions to take on that flow. We can apply ingress metering, in which we can limit the amount of that flow coming into the network. We can then apply certain functions and behaviors to those frames. We can then do a lookup to know where to send that traffic to. Then apply the class of service mapping, in which the quality of service of that flow can be directed to a particular queue to then get specific treatment for its class of service. We can then apply a shaping function to again address the rate at which that flow is entering into the network, and that's called egress shaping. That's what the demo will focus on. And finally, some egress treatment of that flow as it leaves the device into the network. So in this particular demo, we're going to focus on the back end of the pipeline, meaning we need to do the lookup to know where we're going to forward the packet to in order to reach its destination. We're going to go through the class of service mapping to egress queue, and then we're going to shape that flow to a particular egress shaping profile. And then we're going to schedule that flow to allow it to enter into the network. Now, Ciena's vSwitch at this time is based on DPDK. DPDK has its own traffic management pipeline from ingress to egress, and it is actually modeled very similar to Ciena's traditional NID data path pipeline. So in the demo, what I'm going to give you a context for is what we're demonstrating in terms of the egress data path pipeline. Now, it's not the complete pipeline, but it is a subset that we have available to demonstrate today. Now, some of those elements, again, as I mentioned earlier, is the class of service mapping. When a priority is assigned to a particular traffic flow, that flow needs to be assigned to an egress queue. Once that queue is assigned, we can then perform additional functions to provide the appropriate treatment of that flow. So we have 4 queues implemented today in our vSwitch, and the flows that we're going to demonstrate will be directed towards one of those queues initially. And then out of that queue, we will schedule it based on a round-robin scheduling algorithm. And then we will shape that flow based on a shaping profile that is configured. Now, the shaping that we're going to demonstrate is based on a port level shaper. However, again, this is just a demonstration. We do have the ability to shape on a per queue basis as well. In addition, we're only demonstrating single level queuing. The Ciena vSwitch will be capable of supporting hierarchical egress queuing. When we talk about egress shaping, we typically talk about an egress bandwidth profile. The profile consists of a dual leaky bucket algorithm in which there's a committed information rate and an excess information rate. And along with those information rates is the burst size, a committed burst size and an excess burst size. Now, this dual rate egress shaping meter can be configured on a port level, but it can also be configured at the per queue level. In this particular demo, we're going to demonstrate the port level shaping function. Now, the way a shaper works is when traffic arrives at an egress queue and it is scheduled by the scheduler to egress the device, the frame size representing that packet flow gets admitted into one of the buckets. In this case, it's always admitted into the green bucket or the CBS bucket. As the frames flow into this bucket at up to a certain rate, once that rate is exceeded, that excess flow falls into the EBS or the excess burst size bucket. Once that excess burst size bucket is exceeded, we then get into a condition called egress queue congestion. At that point, there are many actions that could be taken. In most cases, what happens is the queues start to fill up. Once those queues end up filling up, we then start discarding the traffic. Now, what we're going to do is demonstrate all these functions, the class of service mapping, the scheduling, and the egress shaping, using a multicast video stream. Now, to set up the context for the network, we have two NIDs. The first NID is an x86 server. It is running Ciena's virtual switch as a vNID, so running on top of Ciena's hypervisor and base OS. It has no hosted VNFs in this case because that's not the focus of this particular demo, but we are demonstrating that when running Ciena's vSwitch or vNID on bare metal, we can get all of the traffic management capabilities that we are traditionally familiar with in Ciena's physical NIDs. At the other end of the network is a second device, which happens to be the 3906 MVI. In this case, the 3906 MVI is strictly acting as a physical NID. We're not hosting any NFV functions on that device. Now, we have two services that we're establishing for this demo. The first is the multicast video stream that originates from a broadcast video server in the network. And it is terminating on a TV. And that video stream will continue throughout the test. We have a second service that's established to run excess traffic or background traffic to induce a congestion state in the network. And I'll walk you through the specific steps of what we're trying to show. Now, for both of these services, you'll notice that I've labeled them both as cost zero, meaning they're sharing the same quality of service through the network, and meaning they're going to contend for the capacity that's available in the network. Now, in addition, what we've done on x86-1 is we've set up an egress bandwidth profile with a committed information rate of 500 megabit per second and a committed burst size of 10 megabytes. There will be contention for the capacity of the shaper, and in doing so, some of the traffic will get discarded. Okay. So we're starting the test stream. We're using a third-party tester, and in doing so, we're inducing 500 megabits of traffic. We're inducing 500 megabits of traffic through a 500 megabit per second shaper, and the multicast video stream is an additional 40 megabit per second stream. And so we end up in a case where we're trying to push 540 megabits of traffic through a shaper of 500 megabits per second. Now, obviously, the outcome is the video stream is impacted, and we see some corruption on the video stream. Now, in order to demonstrate, so what we've demonstrated here is that, we've got contention for the same queue, but we're going to now walk through how we remediate this by exercising some of the features in the egress pipeline of the Ciena virtual switch. So in providing a higher priority to the video stream, we are remediating the contention for the lower priority queue, in which now we can exercise the class of service mapping by having the video stream map its higher class of service to a higher priority queue. We can also demonstrate how we exercise the weighted round robin algorithm, in which the scheduler can now provide preferential treatment to the higher priority queue. What we expect to see after doing this is the video stream clears up. So we're using a netconf-yang configuration tool to set up a higher class of service for the video stream. And once that class of service change takes effect, we can see that the video stream now gets cleared up. There's no longer contention because it's getting the preferential treatment from the scheduler.